Good morning, we are Sonia Rivas and Irene Vilà. In this video, we are going to explain you the circuit architectures known as pipeline and parallelism, as well as the benefits of its utilization. During our presentation, we will go through the following points. First of all, a brief introduction of our topic. Next, we will show you some choices you can take for reducing power consumption in our circuit design. After that, the concept of parallelism and pipeline will be explained. Finally, we will extract some conclusion and propose you some exercises related to the topic of this presentation. What do we want when we design a circuit? We look for techniques that reduce the power consumption while maintaining the throughput. But how do we do that? Regarding the following equation, that corresponds to the total power consumed by a circuit, we can extract some facts. As the first term is the dominant one, we will focus our analysis in lowering it. As you can see, in the circuit design there are different ways to reduce power consumption. It is necessary to take into account different trade-offs, keeping in mind which parameter we care more. We are not going to explain these aspects due to they are not related to our main topic, even though they are very important to reduce power consumption. For our topic, an important fact is to scale voltage. This is because of the fact that delay is increased with the decreasement of the supply voltage. As our target is to obtain a power consumption, we look for the lowest rate. So we need a compensation for the bigger delay. In order to achieve this, the best family logic is CPL, assuming a low threshold voltage. Moreover, the transistor size will play an important role to achieve our objective. We have seen there are a lot of ways to lower power consumption. Now we will enter in the main topic of this presentation, decreasing power consumption by changing the architectures of circuits. As we have said, we are going to focus our analysis on minimizing the power consumption, working at a low rate with a minimum power supply. In order to do this, we know two models, parallelism and pipeline. The usage of one or another will depend on your requirements. For example, if we need to increase our clock period, the best choice will be parallelism, while if we are interested in decreasing the critical path, we will choose the pipeline method. To better explain both architecture methods, we will apply them to this circuit that consists in another with two inputs, A and B, whose output is compared to a shared input C. We can see the output of the registers related to A, B, and C. The information is registered after a register delay. After the delay of the other, we obtain its output. When the result of the other is set, the comparator has a delay until having its result. Moreover, we know that the circuit needs the output to be stable at setup time. So we have that the clock period has to be greater than the addition of the delays of the registers, the other, the comparator, plus the setup time.
Parallelism consists in duplicating the original circuit by halving the clock frequency and adding a multiplexer at the output. This multiplexer works at the same frequency as in the original circuit. Now we're going to analyze the chronogram of the circuit applying parallelism. For the first rising edge of the clock, we have the same performance as before with the same delays. At the falling edge of the clock, the duplicated circuit updates its registers and also works at the same way. Now we'll see the improvement of this architecture. By applying the second clock that has the double of frequency than the clock 1, we can see that we obtain the output from the first part of the circuit at the rising edge of its clock, and the output of the bottom circuit at the next rising edge. You observe that with this method we obtain the double of information and faster. The main drawback of parallelism is the increasement of the area needed for the circuit. Another method we're going to study is pipeline. Pipeline consists in placing new registers to separate the circuit's operation into parts. To achieve this, in our case, we'll place new registers before the comparator. We are now going to analyze how it works. As you can see, the registers of inputs A, B, and C are updated at the rising edge of the clock, and after a delay the result of the other is shown. As we have separated the circuit's operation into parts, at the following rising edge the registers placed before their comparator are updated, and we can obtain the output after the delay of the comparator. It is shown that the critical path will be determined by the maximum delay of each part. Thanks to this, we could adjust the clock period and reduce it. It's also important to mention that we could also consider the delay of the registers. We have also analyzed the power consumption with each solution in reference to the original circuit. In parallelism, we observe that the capacitance has increased by a factor of 2.15. This is because the data path capacitance has increased by a factor of 2, and it also exists some extra routing. Moreover, since the speed requirements to maintain the throughput at the output have halved, the supply voltage can be dropped. The frequency has also halved, because we have doubled the capacitance. In pipeline, we can notice that the supply voltage has dropped by a factor of 0.58. This is because we have considered the same delay in the other and in the comparator. The capacitance has also increased by a factor of 1.15 due to the extra latches. Finally, we have analyzed the combination of both techniques at the same time, which results to be the best solution. In this slide is shown a comparing table with the values obtained. We see that using pipeline and parallelism implies a big reduction of the power consumption comparing with the original circuit. We also observe that parallelism reduces more the power consumption, but the best option is the combination of both methods. To finish our presentation, we are going to present the conclusions extracted from our study. At the beginning of the presentation, we showed different methods to lower the power consumption of circuit, and we've presented the architecture methods of pipeline and parallelism, but which are the benefits and drawbacks of each architecture method. In parallelism, we are able to decrease the clock frequency of the circuit while increasing its data rate at the output. This is achieved by doubling the clock frequency of the multiplexer placed at the output. It also implies a reduction of the power consumption. The main problem of using parallelism is the increasement of area. This is a restriction if we have a limited area to place our circuit. Otherwise, the benefits of parallelism can be seen from another point of view. If we decide to maintain the supply voltage and work at the same frequency, at the output we can obtain the information at the double of the original frequency. By doing this, the power consumption is not reduced, but we improve the speed of the circuit. So, depending on our requirements, we could take advantage of parallelism by increasing the speed of the circuit or reducing its power consumption. In pipeline, we can optimize the critical path. It allows us to reduce the logic debt and that power contributed to hazards. Although the reduction in power consumption is lower than in parallelism, it is the solution to the area issue. Here you can find our information sources. We have proposed you different exercises. The first one consists in some theoretical questions about our presentation. The second one asks you to combine parallelism and pipeline and calculate each delay. The last one consists in an 8-bit adder and pipeline. We hope you have enjoyed our presentation and thank you for your attention.